This next one, I'm going to calculate the equilibrium constant. So the first thing I need to do is write the equilibrium expression for that equation. Now, products over reactant concentration, NCl3 to the second power divided by nitrogen gas and chlorine gas cubed. So now I'm simply going to go through and add each concentration so that NCl3, nitrogen trichloride, is 0.141. No need to include the molar here. These numbers, the K's, are not going to have units. That's good news for once. This number is 0.000104 to the first power. And my chlorine concentration is 0.000201. And that number is cubed. So I'm going to plug this in my calculator. And I get a very large K value. Typically, K values are small. However, this one is K equals 2.35 to 3 significant figures times 10 to the 13th. We got a pretty large number there. No units, as I said before. So if I have a large number and it's products over reactants, that means I have a whole lot of products. Okay? A very small number would mean I have a whole lot of reactants, or it favors reactants. So typically, a number smaller than 1, K value, if K is greater than 1, that means it favors products, or I have a greater percent of products made than reactants. If K is less than 1, that means it favors reactants. Or lies to the left. Now, Le Chatelier's principle is when I have something that is at equilibrium and I impose a change upon that, it's going to change accordingly. So it's going to shift in one direction or the other in order to maintain balance again. So, for example, let's do this macroscopic kind of mechanical example. I have a scale here. It's perfectly balanced. And I add some weight to this side. Now what's going to happen is either I'm going to have to shift some weight this way, or I have to add some weight to this side in order to balance that again. So that's the same principle here, and I can do a few different changes. Now first is I'm going to increase the amount of nitrogen gas. I find nitrogen in my equation here. So just like our balance there, I'm going to have to add some of this in order to balance it. So this is going to shift the equation to the right, or towards products. I typically just do an arrow. Now the next one, a decrease in hydrogen gas. Find hydrogen gas right here. So if I'm removing some of that, I need to go towards it to replace what I lost in order to balance it again. So this is shifting to the left to replace it. Now, increase in temperature. For this, you have to look. This is an exothermic reaction. It's negative. So what I need to do is remember that it's producing heat. So what I do is write heat just like it is a product. If it was endothermic or a positive number, it would go on the reactant side or the left. However, this is exothermic, so it goes on the right. Now, I treat it just like I was treating concentrations. If I am increasing the heat or temperature here, it is going up on the right, the product side, so therefore it's going to shift left. Now, an increase in volume. Volume only applies to gas because solids and liquids take up relatively little space compared to them. So what I'm going to do is look and see that I have 4 moles of gas on the reactant side or the left, and I have 2 on the right. So the 4 moles of gas require more space than the 2 moles of gas, since all gases take up the same amount of space. Now, an increase in volume would kind of give it more room to stretch out. So the side with 4 moles would be favored. So it's going to go to the reactant side or the left. Okay? The last one is the addition of argon gas. Now, if I look on here, argon gas is a noble gas, and it's not in my equation. So if I am adding something that is not in the equation, it's really not doing anything. Okay? So the addition of something not in my equation that's not going to react with anything in my equation, I should add, such as a noble gas, it's going to have no effect